Something just happened deep in the cosmos. Something so powerful, so unfathomably bright, that it outshone entire galaxies in a single blinding instant. It started as a faint shimmer, a distant flicker of light buried within the vastness of space. But within moments, that flicker erupted into a force unlike anything astronomers had ever seen before. Telescopes across the world registered the anomaly, and data streams flooded observatories with readings that made no sense. This wasn't just any explosion. This was something bigger, something far beyond the limits of our understanding. The A signal came from a galaxy over 1 billion light-years away. At first, astronomers thought they were witnessing an ordinary supernova, the explosive death of a massive star. But as the brightness continued to rise, far surpassing what should have been possible, one thing became disturbingly clear. This was no ordinary event. It was the most powerful supernova ever recorded, a cosmic detonation so immense that it defied the very models scientists had relied on for decades. The numbers were staggering, an explosion nearly 100 times brighter than a typical supernova, unleashing more energy in a few seconds than our sun will produce in its entire lifetime. And then came the strangest part. The explosion wasn't behaving the way it should. Instead of fading away as expected, its light refused to dim, burning with an intensity that seemed almost unnatural. Something was keeping it alive, something unknown lurking at the heart of this cosmic catastrophe. Scientists scrambled to explain it, but theories fell short. Could it be a magnetar, an ultra-dense neutron star with a magnetic field trillions of times stronger than Earth's? Or was this something far more exotic, something that defied even the most extreme physics we know? The deeper astronomers looked, the more unsettling the mystery became. Because hidden within the energy readings was a pattern, a strange, pulsing signature that seemed deliberate. Almost as if, somewhere in the heart of this explosion, something was trying to send a message. For centuries, supernovae have been some of the most spectacular and violent events in the universe. These colossal explosions mark the death of massive stars, unleashing more energy in a few weeks than our sun will emit over billions of years. But while humanity has witnessed many of these cosmic cataclysms before, nothing in recorded history even comes close to what was just detected. Astronomers first spotted the anomaly using the Zwicky Transient Facility, an advanced sky survey telescope designed to catch sudden changes in the night sky. Within hours, observatories worldwide turned their eyes toward the distant galaxy where the explosion had occurred. The Hubble Space Telescope, the Chandra X-ray Observatory, and the James Webb Space Telescope all locked onto the source, feeding back data that stunned scientists. This supernova wasn't just big, it was rewriting the rules of astrophysics. For decades, the largest known supernovae had already pushed the limits of scientific understanding. Events like SN 2006 GI and SN 2015L, known as superluminous supernovae, had challenged existing models by producing far more energy than standard stellar deaths should allow. But this new explosion eclipsed them all. It wasn't just the brightest supernova ever observed, it was nearly 100 times brighter than any known stellar death. The numbers didn't add up. The mystery deepened when researchers at NASA's Goddard Space Flight Center and the European Southern Observatory analyzed the event's spectral data. The explosion seemed to have released an enormous amount of hydrogen, a trait usually associated with stars much smaller than the ones capable of producing such powerful supernovae. It also showed an unexpected infrared afterglow, something that should have faded quickly but instead persisted, glowing eerily in the void. The implications were staggering. If this was truly an unknown type of stellar death, it could change everything we thought we knew about the life cycles of stars. Some theorists even proposed a more radical idea. What if this wasn't just a star collapsing, but something even more extreme? A failed supernova, a moment where a star should have died, but instead gave birth to something entirely new. Whatever the answer, one thing was certain. Astronomers weren't just looking at another dying star. They were witnessing a cosmic event unlike anything seen before. And the deeper they looked, the stranger the mystery became. The first alert came in the dead of night. an automated signal from the Zwicky Transient Facility. A telescope stationed in California had detected an abrupt, blinding flare in a distant galaxy over 1 billion light-years away. At first, astronomers assumed it was just another supernova, one of thousands they catalog every year. But within minutes, something became clear. This wasn't just a bright star collapsing into oblivion. This was something else, something far bigger. Within hours, observatories worldwide locked onto the source. The Vera C. Rubin Observatory in Chile, the Chandra X-ray Observatory, and NASA's Swift satellite all trained their instruments on the same patch of sky. The Hubble Space Telescope captured the explosion in real time, and what it revealed defied explanation. The light pouring from this cosmic detonation was unlike anything ever seen before. Bright enough to outshine its entire galaxy, its energy output measuring 100 times greater than even the most powerful supernovae ever recorded. The explosion was so intense that, for a brief moment, it could have been seen with the naked eye if it had occurred in a closer galaxy. But then came the real shock. As astronomers analyzed the data, they noticed something strange. The explosion wasn't fading the way it should have. Normally, a supernova reaches peak brightness and then begins to dim over days or weeks. But this event, it wasn't dimming at all. If anything, it was getting brighter. It refused to follow the rules. Astrophysicists at MIT and the Max Planck Institute rushed to analyze the radiation signature, hoping to find clues. What they found only deepened the mystery. The event wasn't just producing visible light. It was emitting an unusual mix of X-rays, gamma rays, and even radio waves, suggesting that something far more exotic was at play. Some theorized it could be a magnetar, a highly magnetized neutron, star formed in the wake of a supernova. But even that didn't explain the sheer magnitude of the explosion. Others proposed it could be the collapse of a star so massive that instead of forming a black hole, it created something entirely new, a theoretical object that had only existed in equations before now. Then came the most puzzling discovery of all. Hidden within the energy readings was a faint, repeating pulse, almost like a heartbeat, buried beneath the chaos of the explosion. At first, scientists dismissed it as background noise, interference from distant cosmic sources. But as more telescopes locked on, the pattern persisted. It was structured, rhythmic, and, most unsettling of all, it was shifting, as if responding to something. This wasn't just an explosion. This was a message written in light, carved into the fabric of the cosmos itself, and no one had any idea what it meant. For a supernova to reach such staggering levels of brightness, something extraordinary must have happened. Normally, when a massive star reaches the end of its life, it runs out of nuclear fuel, collapses under its own gravity, and then explodes in a brilliant burst of energy. The remaining core usually forms a neutron star, or, if massive enough, collapses into a black hole. But this explosion? It broke every rule in the book. One leading theory is that this could be a pulsational pair-instability supernova, an ultra-rare type of stellar explosion that occurs only in the most massive stars, monsters over 150 times the mass of our Sun. In such cases, the star becomes so hot that high-energy gamma rays spontaneously create pairs of electrons and positrons, disrupting the normal balance of pressure and gravity. This instability leads to a series of massive outbursts, each one growing stronger until the star detonates in a final cataclysmic explosion. But even this extreme scenario doesn't fully explain the anomaly. Another possibility is that the explosion left behind a magnetar, one of the most exotic objects in the universe. Magnetars are neutron stars with magnetic fields so intense that they can twist and bend the very fabric of space around them. If a magnetar formed at the heart of this explosion, it could be injecting vast amounts of energy back into the supernova, causing it to shine far longer and brighter than normal. But even the most powerful magnetars we've ever detected wouldn't be enough to explain this level of luminosity. Something else is at play. And then there's the strangest theory, the idea that this event could represent an entirely new class of cosmic explosions, one we've never encountered before. Some researchers suggest that instead of a dying star, we could be witnessing the birth of something unprecedented, a new kind of compact object that challenges our understanding of physics itself. Could this be a direct collapse into a quark, star, or some unknown form of matter? Could dark energy or exotic particles be influencing this event? The biggest question remains unanswered. What's causing the mysterious pulsing signal buried in the explosion's radiation? If it were natural, we'd expect it to behave like pulsars or other known astrophysical sources. But the fact that it appears structured, rhythmic, and even changing over time has left scientists scratching their heads. Imagine hearing a random series of drum beats, only to realize they are forming a repeating pattern, one that doesn't belong to nature, but to something else. That's exactly what astronomers are now trying to decode. For now, the answers remain just beyond our grasp. But one thing is certain: this explosion has rewritten the laws of astrophysics, and whatever we discover next could change everything we know about the universe. But here's the part that has scientists truly baffled. Just when they thought they had gathered enough data to categorize this event, something happened that defied all logic. A deeper analysis of the radiation signature revealed an anomaly, one so subtle that it had almost been overlooked. The pulsing signal buried within the explosion's afterglow wasn't just structured, it was shifting in a way that shouldn't be possible. At first, researchers assumed it was a natural variation in the dying star's final moments. But as they continued analyzing the frequency shifts, they noticed something eerie. The pulses weren't random. They followed a mathematical sequence, one that bore a striking resemblance to prime numbers. In astrophysics, naturally occurring signals tend to be chaotic, dictated by the violent forces of the cosmos. But prime numbers? Those are different. They suggest order, structure, intelligence. The implications were staggering. Could this be the first piece of evidence that we aren't alone? Was it possible that something or someone was harnessing the power of a supernova to send a message across the universe? Some scientists dismissed the idea outright, arguing that natural processes could still be responsible. But others weren't so sure. The more they studied the signal, the harder it became to ignore the feeling that this was deliberate. And then came the final twist. The pulse was accelerating. Over weeks of observation, the signal had been changing, adapting, almost as if it were responding to something. But responding to what? For now, no one knows the answer. The signal remains a mystery, an unanswered question etched into the explosion of the most powerful supernova ever recorded. Some believe it's just an unexplained quirk of nature, a new cosmic phenomenon yet to be fully understood. But others, they're beginning to wonder if we've just intercepted something much bigger, something not of this world. So, what does this all mean? Have we just witnessed the most powerful stellar explosion in the universe's history? Or is there something more hiding within the data, something we have yet to understand? The idea that a supernova could produce a structured, evolving signal is unlike anything ever observed. It challenges everything we thought we knew about how stars live and die. And if there is even the slightest chance that this signal is more than just a cosmic anomaly, then we could be standing on the edge of one of the greatest discoveries in human history. One thing is certain: this event has changed the way we look at the cosmos. It has reminded us that the universe is far more complex, mysterious, and awe-inspiring than we could ever imagine. Could we be on the verge of unlocking something that has been waiting for us to find it? Or is this simply another riddle the universe has thrown our way, daring us to solve it? What do you think? Is this just an extreme cosmic explosion, or could there be something hidden within the light? Let me know in the comments below. And if you want to stay updated on the biggest discoveries in space, don't forget to subscribe. The universe is full of mysteries. Let's explore them together.